Hi everyone, I'm going to be doing a video today on angles and parallel lines and angles and polygons. This is a topic that can appear on both the foundation and the higher tier papers, and it can be either a calculator or non-calculator topic. So you should be able to do these questions without a calculator because all you're really doing is multiplying, dividing, adding, subtracting. But of course, if you do have a calculator and if it is on a calculator paper, it's worth using that calculator just to speed things up a little bit. So the first thing you need to know are the three different types of angles and parallel lines. I've drawn them out for you here. Make sure you know the names of them. It's not enough to call them a Z angle or a C angle, for example. You need to know that if they form a Z shape like they do here, they're alternate angles. If they form an F shape, they're corresponding. And if they fit inside a sort of C shape, they're called either supplementary or co-interior angles. Bear in mind as well that the Z, the F, and the C might not always be quite this obvious. They might be like a sideways Z or an upside down F or a backwards F in this case. So just bear that in mind. The next set of rules that you need to know are the rules for angles in polygons. So you should know that the exterior angles of any polygon sum to 360, and you probably already know the first few sums of interior angles of the easier shapes like your triangles, your quadrilaterals, your pentagons, but it's important that you understand why they follow that pattern of adding on 180 each time. The easiest way to do this if you forget it in an exam is to draw yourself a quick little shape. So if you're dealing with a quadrilateral, draw a quadrilateral. It doesn't have to be a perfect square. Any quadrilateral will do. Pick one of your vertices. So I'm going to start on this one here, and I'm just going to connect it to the other sides of my shape. You don't have to use a ruler for this. So you have two different triangles now, and we know that the interior angles of a triangle add up to 180. You learned that back in primary school. So that means that that triangle there has a sum of 180, and that triangle there has a sum of 180, and 180 times by 2 gives us our 360. So do the same thing for any shape. If you've got a pentagon, a five-sided shape, again, just draw out a pentagon, pick a vertex or corner of your shape. I'm going to go for that one. Connect it to the other vertices, and you will quickly see that you can only fit 3 triangles inside a pentagon. Again, I know that the sum of the interior angles of any triangle are 180. So if I do 180 times by 3, that gives me the sum of 540. It doesn't have to be a regular shape. Any pentagon will have interior angles adding up to 540. So that's where this formula comes from. You don't have to memorize the formula, as long as you remember that the number of sides take away 2 times by 180 gives you the sum of the interior angle. So for example, in a pentagon, you've got 5 sides, 5 take 2 is 3, that's how many triangles you can fit in, and 3 times by 180 is your 540. So if I told you that you had a 20-sided shape, you shouldn't need to draw that out. You can just do 20 take away 2 is 18, and 18 times by 180. So let's go ahead and look at some questions then. And we're going to start nice and easy with the following question. So, starting with this question here, you are told that A, B, and CD are parallel lines. We can also see here we've got the symbols telling us they're parallel lines. An angle of 110 is shown. We want to write down the letter of one other angle of size 110. I'm going to do you one better. I'm going to give you a few different ones. So first of all, we've got opposite angles here. This has nothing to do with parallel lines. It'll work for any set of lines that cut across like that in that sort of X shape. So B has got to be 110 degrees. So you could say that 110, B is equal to 110 because it's a vertically opposite. I'm just going to write that down here as well. Because in part B they do ask for a reason. So I need to make sure I'm using mathematical language. You could also say that you've got some alternate angles here. So if I create my backwards Z there, that must mean that D is also 110. And again, you can say that that's because they are alternate angles. Or of course you could form some corresponding angles here. So I've got my backwards F going down here and here, which means that F there would also have to be 110. And again, that is because it's corresponding. So any of those answers would suffice. But again, make sure you're using that mathematical terminology. If it has to give a reason, you need to be using words like alternate, corresponding, opposite, or supplementary or co-interior. Let's have a look at another question then, and let's make it a little bit more challenging. So again, bear in mind, even if you do do the foundation paper, you could get questions like this. So you're told here that A, B, and C, D are parallel. Again, we can see the parallel symbols there. Angle HIK, so I'm going to figure out what that is by tracing it with my pen. HIK, that's this one here, is 85 degrees. I'm going to go ahead and write that down. My suggestion to you would be to always work on the shape. Draw out the angles that you know, use a highlighter or a different colored pen if you've got one, or even just your regular pen to draw out the shapes you need. Don't try to do it further down on the page, just do it straight on the diagram. Angle BFH is that one there, that is 32 degrees. And they're telling us to find the size of angle FEG. Well, FEG is that one, so that's the one I'm trying to find. So let me just deal with what I know for sure. So I'm going to start with my vertically opposite angles because they're the easiest. Got a little cross there. That must mean that those two are equal, so that's got to be 32 degrees. And already I can see that I'm working with a triangle here. So if I can work out that angle there, I should be able to work out that one really easily. So if I just turn my page here, I've got an angle there, I've got an angle there. They don't look like they're the same. However, I'm just going to turn it back. I can create some corresponding angles here and go from there. So if I create my corresponding angles there, that must mean that that angle there is corresponding to that one. So that is 85 degrees, which might not seem particularly useful yet until I realize that I've got two angles on a straight line there. So if I just do 180 minus my 85, that should give me that angle there. And just to speed things up, I am going to use my calculator. If this was a calculator paper, that would be the best bet to ensure that I don't make any silly mistakes. But obviously, if you haven't got a calculator, you can do it in your head. That is 95 degrees. So that's that one up there. And then again, I've got angles in a triangle. So if I add those two and take them from 180, 32 plus 95 gives me 127. And I'm going to take that away from 180. Which gives me 53 degrees. So that must mean that the angle FEG is 53 degrees. And that would ensure that I get full marks on that question because I've shown all my working out either on my diagram or further below. So let's go ahead and have a look at an even more challenging question then. Got this one here. The diagram shows three regular pentagons. So remember, we've got two keywords here. We've got the word regular, and then we've also got the word pentagon. So pentagon means it's got 5 sides, and I'm probably going to be dealing with interior angles here. So straight away what I would do is I'd work out the sum of my interior angles by using that formula from earlier. So I'm going to be using this formula here. So it's got 5 sides. So if I didn't remember what the total was, I would just do 5, take away 2, which is 3, times by 180, which is of course 540 degrees. So I know that all of the angles inside each of my pentagons will have to add to 540. Regular means that all the angles are the same. So I can work out one angle quite quickly. So if I know, for example, that in this pentagon, these 5 angles add to 540 and they're all the same, all I've really got to do is 540 divided by 5, because there's 5 angles, to work out one of them. Again, you can do this in your head or use your calculator depending on the type of paper you've got. That is 108. So that angle there is 108. So is that one. So is that one. But more importantly, that one there is 108. And so is that one there, because we know that these are all regular pentagons. So what I've now got are 3 angles of 108 and then one more angle of x. Together, around a point, they have to add to 360. So if I do 108 times by 3 and take that from 360, that should give me my answer. So that gives me an angle of 36 degrees. Therefore, x is 36. And there's your answer to that one. Okay, and let's look at one final question together. So we are told here that shape A is a regular triangle. Again, you've got some key words here. Regular triangle implies that all the angles are the same. So I know that the angles in a triangle add up to 180. If I do 180 divided by 3, that will give me 60 degrees. So each of these angles is going to be 60 degrees. And then I have a regular octagon. An octagon has 8 sides. So I'm going to do 8 take away 2 is 6, because there's going to be 6 triangles in that shape. 6 times 180, use my calculator to speed things up, is 1080. And it's regular, so I know that all of the angles are the same. So if I do 1080 divided by 8, that's going to give me an angle of 135. So I know, for example, that that angle there has got to be 60. That one's there has got to be 135. That one there has also got to be 135. And I'm told that another regular polygon P is shown. So that one is a regular polygon as well, meaning that that angle there, I'm going to do it in a different color, must be equivalent to that angle there. How many sides does polygon P have? Well, I'm going to use what I know. This bit here, I've got an unknown value, so I'm not going to worry about that. I'm going to focus on this bit here. I've got an angle of 60 degrees and an angle of 135, and then my unknown angle. So what I'm going to do is I'm going to start by adding 60 and 135, which of course gives me 195. And then I'm going to take those away from 360 because they make a full circle. I'm going to use my calculator to make sure I don't make any silly mistakes. That is 165 degrees. So that one there is 165 degrees. Now, I'm a bit stuck now because it's asking me for the number of sides, and I know from what I was looking at the start that every shape, every polygon has a different sum for its interior angles. However, I also know that every polygon, every single polygon, has the same sum for its exterior angles. So if I know that one of my interior angles is 165, I'm just gonna draw this like this. This is shape P, or part of shape P. That angle there is 165 degrees. I can work out this exterior angle here because together they make a straight line. So 180 take away 165 gives me 15 degrees. And if I know that I've got n number of sides in P, each of which has an exterior angle of 15 degrees, and each one has to add to 360, I can do 360 into 15 to work out how many sides it's got. So it appears that shape P has 24 sides. So there's some examples on angle reasoning with angles and polygons and parallel lines.